All right, let's dive into something we use every single day but maybe don't think about: hubs, switches, and routers. These are basically the unsung heroes of the internet, the devices that took our networks from complete chaos to the seamless connection we all expect. So let's get into it. I mean, it's a pretty basic question, right? You click on a website and boom, it's there. You fire off an email and it shows up halfway across the world. But what's really going on under the hood to make that happen? To get to the solution, we first have to really understand the problem they were trying to solve. Just picture this for a second. In the very early days of networking, connecting computers was literally like throwing them all into one giant room where everyone had to share the same phone line. If one computer wanted to talk, every single other computer had to listen. And if two of them tried to talk at the same time, well, you just got noise. It was a total mess, inefficient, not secure, and there was no way it could ever scale up. So let's take a closer look at this chaos. What were the actual problems with having just one single shared connection for everyone? Oh man, the list of problems was long. First, you had these constant data collisions that would just grind the network to a halt. There was absolutely no traffic controls, so no way to direct information where it needed to go. On top of that, you couldn't separate different networks, and a single broken device could literally take down the whole system for everyone. It was, a nightmare. Let's really focus on that biggest problem: collisions. It is exactly like two people trying to talk at the exact same time. The messages just get garbled, nobody understands anything, and both people have to stop, wait, and try all over again. On a network, this constant stopping and restarting was just brutal for performance. Something had to change. So, the first attempt at a solution comes onto the scene, and that was the hub. You can think of it like the network's really loud, but kind of simple town crier. A hub's job is incredibly basic. It's really just a central point to plug everything in. When a signal comes in on one of its ports, the hub doesn't think. It doesn't analyze anything. It just takes that signal, makes it louder, and blasts it out of every single other port. It's not smart at all. It's basically just a repeater. So what did the hub actually fix? Well, to be fair, it did clean up the wiring mess by giving us one central box to plug everything into. But, and this is a big but, it did absolutely nothing to solve the real problem. It was still one big chaotic shouting match. All it did was put that shared phone line inside a little box. And this brings us to a super important idea: the collision domain. You can see here a hub operates at OSI layer 1. Don't worry about the OSI model too much, just think of layer 1 as the most basic physical level, the actual wires and electrical signals. For a hub, this meant the entire network was one giant collision domain. A collision anywhere affected everyone. It was a tiny step forward, sure, but it didn't solve the core issue, which is exactly why hubs are completely obsolete today. Okay, so the network clearly needed some intelligence. It needed a postmaster who could sort the mail, not a town crier who just shouted everything. And this brings us to our second, much smarter hero: the switch. Now this was the real game changer. Unlike a hub that just shouts to everyone, a switch acts like an intelligent traffic controller. It actually learns where each device is on the network and delivers data only to the specific device that's supposed to get it. I mean, just look at the massive leap forward here. A hub mindlessly yells at everyone. A switch delivers a private message, and how does it do that? It learns the unique physical address, the MAC address, of every single device plugged into it. And the result? This is huge. Instead of one giant collision domain, a switch creates a separate private one for every single port. Collisions basically became a thing of the past. So a switch operates at layer 2, using those physical MAC addresses to work its magic. By giving each port its very own collision domain, it pretty much solved the collision problem overnight. And that is why the switch became, and still is, the most common device you'll find building local area networks, or LANs. Okay, so this brings up a really interesting question. If a switch is all about sending these private, one-on-one messages, what happens when a computer actually needs to make an announcement to everyone on the network? This is what we call a broadcast. It's a message that's meant for everyone. A perfect analogy is shouting in a classroom, "Hey, who has my pen?" Your computer does the same thing, shouting, "Hey everyone, I'm looking for this IP address." When a switch sees this kind of message, it knows it's an announcement and does its job. It forwards it to everyone. And right here, we find the switch's one big limitation. While it's great at stopping collisions, it does not stop broadcasts. So on a big network, all those announcements can create a ton of background noise, slowing things down. And even more important, a switch is a local device. It has no idea how to talk to the outside world. So, to connect our local network to other networks and to control all that broadcast noise, we need our final hero. We need a device that can be an ambassador between our little town and the rest of the world. And that device is the router. A router has two main jobs, and they're both absolutely critical. Job number one, it connects different networks together. Think your home network connecting to the internet. Job number two, it acts like a brick wall for broadcasts, stopping all that local chatter from spilling out and flooding other networks. It keeps the local gossip local. So the router operates one level up, at layer 3, the network layer. Its entire reason to exist is to route traffic between different networks. And in doing so, it naturally breaks up those noisy broadcast domains. The bottom line is simple. If you want to get on the internet, you absolutely have to have a router. So there we have it, our three heroes, the dumb hub, the smart switch, and the global router. Now let's put it all together and see how they line up. This table just lays out the evolution of intelligence perfectly. At the bottom, at layer 1, you have the hub, which is basic. It only understands raw electrical signals. Then you move up to layer 2 with the switch, which gets smarter. It uses local MAC addresses to find devices on the same network. And finally, at layer 3, the router is the smartest of the bunch, using global IP addresses to find its way between different networks all across the internet. So, what does this all mean for building a network today? The takeaways are actually super simple. First, just don't use hubs, ever. Seriously. Second, use switches to build out your fast, efficient local networks, whether that's at home or in an office. And third, use a router to be the gateway, to separate your network from others and connect it securely to the internet. So let's trace the journey. When you click a link, your computer sends that request to the local switch. The switch looks at it, sees the destination is outside the local network, and says, "Not my job." So it forwards it to the router. The router then takes over, figures out the best path, and sends your message on its way out to the global internet. And we'll just end with this thought. Think about your own setup. At home, you probably have one main router, but an office might have dozens of switches. Now you know why, right? At home, you have one network that needs one gateway to the internet. That's your router. But in an office, you have hundreds of devices that all need to talk to each other locally really, really fast. That is a job for a whole lot of switches, which all funnel their internet traffic to just one or two powerful routers. From chaos to connection, each hero plays its part perfectly.